Today we're talking about three-dimensional figures. All the figures that we are talking about today, except the sphere, are what we call a polyhedron. I'll write that out up here. And a polyhedron has to be made up of flat surfaces, and it's going to enclose a single region of space. That's our official definition. So it has to be made up of flat surfaces. It's a 3D figure. It's made up of flat surfaces. It's a 3D figure, meaning it's going to have length, width, and height. And it's only going to enclose a single region of space. And we'll talk about that more a little bit later. It encloses a single region of space. And so we're going to look at labeling some of the parts of any polyhedron. For this one, I'm just going to draw a nice little rectangular prism here, because it's the easiest one. So you draw two rectangles and then you connect the corresponding vertices. And so on any of our polyhedron, we are going to have the flat surfaces, and every flat surface is going to be called a face. And so this would be a face. And on square and rectangular prisms, they have 6 faces. Okay? Everywhere that two faces join, you make a line, and that's going to be called an edge. Okay, so if you're imagining a box right now, right, this would be the edge of the box. The final thing is going to be every corner. Right? So that's where four of those faces touch all at one point, and those corners are called vertices. So this would be one of the vertices would be a vertex. Okay? So that's all of our parts of a polyhedron. Now we're going to talk about some specific polyhedron. And our first one is a prism. So we're going to start again with like a square or a rectangular prism. And we connect all of our vertices here. Okay, and so on here, we always name prisms by their bases. Okay, and prisms are going to have two bases. And the bases are always going to be parallel and congruent. These are parallel and congruent. If you'd rather write the words out on that, you're welcome to do so. Okay? So, for example, if this is a cube, it doesn't matter which two sides you pick because they're all squares. But so this and this face are parallel and congruent. And so those would be our bases. And if these are squares, then this is a square prism. And a square prism has its own special name. We call it a cube. But if they were rectangles, it would be a rectangular prism. Okay. If they were triangles, it would be a triangular prism. Right? Hexagons, hexagonal prism, so on and so forth. All right. You're going to notice that on all of the prisms, the faces that are not bases. Okay, so we've labeled the bases in red here. All of these other faces on here are always going to be quadrilaterals. They're usually rectangles, but they'll always be quadrilaterals. And so that's going to be really important also. Okay, next we're going to talk about pyramids. And I'm going to go ahead and apologize. Pyramids are harder to draw than prisms, in my opinion. And so you're welcome to look in the book and get your own idea about how you could draw a pyramid better than I can. But they are always also named by their bases. So the base of this one is a rectangle, obviously not a square. And if you weren't sure, we could always label our sides here so you would know. And so this is a rectangular pyramid. little bit better right here. Sorry about that. Okay, there's a pyramid. And so a pyramid is only going to have one base. Okay? It's not going to have two like a prism. It's only going to have one base. It's named after that base. So if it's a rectangle, it's a rectangular pyramid. If it's a hexagon, it's a hexagonal pyramid. So on and so forth. But it's only going to have one base. All other faces are triangles. Okay. So you'll notice all of these other faces up here are going to be triangles. All right, and this one over here would be a triangle. Okay. All four of them in this case would be triangles. So that's a pyramid. Next, we're going to look at what happens if we have some of those bases that are circles. So if we take a prism and we make the bases circles instead of polygons, okay, we end up with a cylinder. Okay, so we have a cylinder here. And so the bases, it's got two bases. Bases are cylinders, or are circles, excuse me. And you're going to need a couple of measurements on here. First of all, let's label our bases. So the red is going to be the base. Those are the bases. And when you're going to plug into your formulas here, you're going to need a couple of things. So you might need the radius. That's going to be the radius of one of those circles. And so it's measured from the center of the circle to the edge of the circle. That's your radius. You might also need the height, and the height is going to be measured from one base to the other. And that's true whether you're talking about a prism or a cylinder. The height is measured from one base to the other. And we'll cover that in class, but it's just a reminder here. Okay. Next, what happens if we take a pyramid and make the base of the pyramid a circle? We end up with a cone. Some of you probably remember these as birthday hats. Okay, so again, our base is a circle down here. And then we have the radius. Okay. And on here we're going to have two different kinds of heights. I'm going to draw them in two different colors. Just the plain old height that you need for the volume formula, I've marked here in green. And it's measured from the vertex, and it's always going to make a right angle with the base. Okay. The second height we have, though, is along one of these edges. And it doesn't matter which one, but it's measured from the vertex along an edge. And that's called slant height. Okay, so L is equal to slant height. So that's a cone. So it has a circular base. And it has a slant height. And that's going to be really important. And pyramids have a slant height too. We'll cover that again in class. I just want to be sure I remind you here. Okay? The last thing we have is a sphere. Okay? And a sphere is going to look like a ball if we're looking at it in real life. Okay? And its measurements, it doesn't have a base. It just has a radius. And so that's the only thing that we have to label on a sphere. No bases, because it's a sphere. It is not a polyhedron. Okay. And there's no lateral surface area. There's only total surface area. Okay. Well, I appreciate you watching, and I look forward to seeing you in class. I hope you have a good day. Thank you.